Okay. Students, in the previous class we discussed what is the magnetic field along the axis of a circular coil. Now we are going to see what is the pattern or what is the pattern of magnetic field around a circular loop. Imagine you have a circular loop. Okay, this is a circular loop, and through this loop a current I is flowing. Now if you look into the closer portion of the wire, you can see the pattern of magnetic field will be concentric circles. Whereas as you move away from the coil towards the center, so imagine if this is my circular coil, near to the wire you will get concentric circles. Now if you move from the wire towards the center, you can see the magnetic field lines are almost parallel and perpendicular to the plane of the coil. See, this is my plane of the coil and the field lines are parallel. There will be a number of field lines and those lines will be parallel and perpendicular to the plane of the coil. So my question is, so I have field, and you know a magnet has two poles, north pole and a south pole. So next we are going to find out the direction of magnetic field, which is my north pole and which is my south pole. Okay, for that you can use the right hand thumb rule. Now imagine you have a circular coil, okay, and the current is flowing in this direction. So just you have, this is your right hand, just curl your right hand the coil. Now the fingers represents the direction of current. See, the current is flowing in this direction, and where is my thumb pointing? My thumb is pointing upward, and the thumb indicates the direction of north pole. So this will be our north pole. So this is my circular coil. I am curling my fingers. So this is the direction of, see, my nails are coming like this. My fingers is coming like this. So this is our current. Current is flowing like this. And my thumb is pointing upward, which means this will be the north pole. Now imagine my current is flowing in this direction. So curl your fingers around your coil. So curl your fingers around the coil. So this is the direction of current. So where is my north pole? My north pole is downward. Okay. See, the lines of force near the wire are almost concentric circles. The lines at the center are almost straight, parallel and perpendicular. The lines are perpendicular to the plane of the loop. Thus the magnetic field is uniform at the center of the loop. Now direction of the field can be obtained using the right hand thumb rule. For that what you have to do? You take your coil, curl your fingers in the direction of the coil. Your fingers represents the direction of current and your thumb represents the north pole. Okay. Next we are going to derive the relation between mu 0, epsilon 0 and C. Permeability of free space, and what is C? C is the speed of light in space. Okay. We know that mu 0 by 4 pi is equal to 10 raised to minus 7 Tesla meter ampere raised to minus 1, and 1 by or mu 0 is equal to 4 pi into 10 raised to minus 7 and 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter square coulomb raised to minus 2, or epsilon 0 is equal to 1 divided by 4 pi to 9 into 10 raised to 9. Next we are going to multiply mu 0 with epsilon 0. So we get mu 0 into epsilon 0 is equal to 4 pi into 10 raised to minus 7 by 4 pi into 9 into 10 raised to 9 is equal to 1 divided by 9 into 10 raised to 16, which is equal to 1 divided by 3 into 10 raised to 8 the square. Now what is 3 into 10 raised to 8 the whole square? 3 into 10 raised to 8, it is the speed of light. So we can write this equation as mu 0 into epsilon 0 is equal to 1 by c square, or c is equal to 1 divided by root of mu 0 into epsilon 0. This is the relation between c, mu 0 and epsilon 0.